Good morning, everybody, and once again, welcome back to the channel. In this particular video, I want to share a very interesting edge case that you might encounter if you are using the last modified date to process file incrementally from an object store like S3. So let me walk you over the problem statement, and then I'll show you a couple of solutions, and then we'll talk more about that, right? So, okay, here is the scenario, right? Now, let's say process P1, it's a thread or a separate process, right? It's uploading a file. It started uploading file at 11 o'clock, right? And there's a process 2 who is also uploading a file. Since it's a shorter file, right? The process started at about 11:02, okay? And the second file is complete around 11:05, right? But the first file, let's say it's a 100 gig file, it's been taking a long time, that gets uploaded at 11:10, right? So simple thing, right? First file gets uploaded at 11:10, second file gets uploaded at 11:05. Now the challenge or the problem is if you run checkpoint, if you run your incremental file processing, right? Let's say you start at 11:05, you will process file F2, right? And then you would commit the checkpoint, right? Now the issue is when the file is uploaded to the S3, right? The last modified file is the upload start time, right? So this F2 started at 11:02, right? You were expecting that the last modified would be 11:05 here, right? No, but it is 11:02, right? That's the thing, right? So if you start the incremental processor, what would happen is, you would process F2 and you would commit the checkpoint to 11:05, right? So the next time you will say, hey, give me files greater than 11:05. Now, when this file particular makes it, the checkpoint is 11:00. So that file is missed, right? So now how to solve this problem? There are three possible ways, and I'll show you a code as well. So the first way is you set up an S3 event, right? So anytime new objects are coming in, you basically buffer them into the SQS queue, and the consumer can, get the files and then basically process and then commit. Commit meaning clean the processed file from the SQS, right? The second approach is if its ordering is important, right? If for some reason ordering is very important, then you can use a Lambda and then forward that to a FIFO SQS queue, right? So that way, ordering is maintained, right? And the third approach that I'm gonna share and for which I'm gonna show you the code is, so whenever you have new files, right? Let's say you do a list operation, you get all the files, and then you move all the file into .pending folder, right? So when I say move, you're not moving the physical file, but you're basically creating sort of like a manifest file with the bunch of S3 URI. Now, once the process runs, it reads the data frame. Once the processing is done, then it will move those files, the S3 URI which it has processed, it will go to the raw zone, delete those files, and of course move it into archive folder, right? So next time the process repeats. So we're gonna take a look at that particular process. All right, so now for the demo, right? Let me show you, right? So first, let's generate some Parquet files. I have a Python file which is gendata.py. This is gonna generate some bunch of Parquet files for me. So I am generating about roughly 10 files on an object store, as you can see inside the raw folder, right? 10 files are there, right? Now I want to show you how that process would look like, right? Okay. All right. So first thing, we create an instance of a class S3 file processor, right? And then we call create pending manifest, right? So what it does is basically it creates inside the pending folder the list of S3 URIs that it needs to process, right? And once it is done, the Spark job reads that. So if I come here, see spark.read text, we read the manifest file and then we read the Parquet files, right? As you can see over here, extract file paths from the manifest and read them as a Parquet file. Of course, I have a small delay to simulate that it's taking a long time, right? And then of course the archival process kicks in, which means the file that you have already processed, move them into an archive folder, right? So the next time the process can repeat, right? And again, this is happens very fast. Okay, so let me show you. So what I'll do is, again, I have 10 files and I'm only gonna process 5 files right now. I have a max file of 5, right? So I wanna show you that, okay? So watch what's gonna happen. So Python 3.py, okay, I started. Now I should be seeing the pending folder. Here you can see that pending folder. It is usually very fast. So again, but I added a delay to show you in the video, right? So if I do run SQL, here you can see a bunch of file that it needs to process, right? Now if I go back to my pending folder, Now let's take a look at the job. As you can see, it is running. Once the job is complete, then it would remove again 10 objects are there in the raw folder, right? Now they are archived, right? So if I now refresh, I have 5 objects here, and here you can see inside archive folder I have 5. Now this process will repeat again when the job runs next time. Of course, again it's going to do a list directory in the raw folder. We have a pending folder. Now all the S3 URI that it again needs to process. The Spark will process the job, and then the archival process will kick in. It will move the file that it has already processed into archive folder, right? So should be very quick, probably. There you go, done. So boom, gone, right? So pending folder is gone. Raw folder is also gone because there are no files to process, and here you can see we have all the 10 files because we already processed that, right? Now another thing that you can do, again I'm just explaining, right? So another thing that you can do, so for example, if you don't want a second process to kick in, right? Let's say that you have scheduled this on a cron, right? Hypothetically, right? And let's say this takes about 20 minutes, right? And the cron fires every 15 minutes, right? Now how to solve this, right? So what you can do is you can now use a pessimistic based log control, right? So basically you can use S3 as a log. So when the process runs, right, it acquires the log, it does this processing, and if by accidentally the second process kicks in, let's say a little earlier, then it has to wait for the first process to release the lock. So that way, at any given point, only one process is running, right? And the Spark job, again, you can configure that n is the number of S3 URI files in your manifest, right? And then each your, of course, Parquet file would have thousands and thousands of records, right? So you can adjust that number, right? Like that n and etc. etc. So that's it. Again, simple approach. Just wanted to show you, right? You can use again SQS based approach, event driven approach, right? Buffer all the message in the SQS, then read the message, write it, and then of course then commit it back to the SQS, meaning it's clean, right? You can use a FIFO queue. There's also one more approach people use often is they write the S3 URI into DynamoDB and they do these scanning operation there in Dynamo. That is also a very valid solution, right? So yeah, I just wanted to point out the solution. I'll leave this code in the description, so in case if you want to check it out. With that being said, I hope you have enjoyed the walkthrough, and if you have any other questions, let me know. Until then, keep smiling, keep programming, and I will see you in the next video.